Good morning, KubeCon, and welcome to Operator Day 2021. Get ready for an action-packed day as we discuss topics as far as Kubernetes will reach, from the enterprise through to machine learning to microclouds on the edge. As a reminder, we have Kubernetes and Cloud Native survey that already has more than 700 people who've responded to it. We're trying to collect as much data for you so we can share it with the community and everyone can see what everybody else is up to. We've got a ton of data in there already, and I think you should see a link popping up on the side of the chat at any time. I'm David Booth, and I'm the VP of Cloud Native Operations, or Cloud Native Applications at Canonical, and I'm here with Mark Shuttleworth, who I think needs no introduction. Mark, 6 months ago, Canonical hosted the first Operator Day at KubeCon. What's happened since then?
Well, really, the focus for us at Canonical has been Kubernetes interoperability, Kubernetes portability. Ubuntu typically sits underneath the Kubernetes implementations that most people are using. Almost every major cloud infrastructure or vendor Kubernetes sits on Ubuntu. So our biggest impact in the ecosystem is really making sure the details line up so that people have portability for their application workloads effectively if they're moving them from Azure to Amazon, or Amazon to Google, or Google to Azure, or Oracle, or IBM, or VMware, those other sorts of infrastructures. So we're working with all of those major vendors to make sure that from the bare metal up through the hypervisor or the cloud, up through the Kubernetes worker, all the way up to the application, the details line up. A big push in the last 6 months, of course, has been working with NVIDIA to get machine learning capabilities cleanly portable between different kinds of infrastructure, so that applications that depend on low-level details like specific GPUs or specific acceleration capabilities, those are also portable across different cloud environments, different kinds of infrastructure, different versions of Kubernetes, and so on. This can be really, really messy, right? There's a ton of stuff that has to be figured out in the Kubernetes ecosystem. The APIs are all standardized, but a lot of the details of implementations can cause problems with portability and interoperability for vendors and for users. So that's really been a big focus for us. Of course, we do have two flavors of Kubernetes that we put out into the market as well. One, microcase, which is optimized for super simplicity for people who don't actually want to know about Kubernetes at all. They just want to standardize, get up and go Kubernetes so that they can focus on their applications. And then the other, charmed Kubernetes, which is really designed for people who want to get deep into Kubernetes and build complex architectures of Kubernetes and work in very specific capabilities, but still keep it all sort of operable and maintainable. So I guess that's consumed most of our attention over the last 6 months. In terms of trends, obviously people are getting really excited about operators, and it's great to see now very widespread enthusiasm for the idea of software driving software, which is really what operators capture. I think in Kubernetes, that was sort of a forced move because the nature of the infrastructure really requires you to get rid of old ideas of configuration management, old ideas of application management, external kind of application management, just because Kubernetes is such a clean reset of the experience that operations people have, right? None of their old configuration management code would work in a Kubernetes environment. So lots of people are now on the operator bandwagon, lots of different ways to create operators on Kubernetes, lots of different frameworks, lots of different energy in that world, which is exciting, but also a little bit confusing, I think. Now you can easily end up, with operators from 10 different vendors written in 10 different ways with 10 different user experiences. The key challenge now isn't writing operators or whether people should use code to drive code, but rather how do you integrate that? How do you create a good user experience of that? How are you going to maintain that in a large organization? And how do we make all of that really usable?
That totally makes sense. It's an interesting space that we're in right now. It feels really, really early, and feels like there's a lot of stuff that's happening and a lot of changes right now. So I'm looking forward to this as it goes forward. Well, what hasn't changed since the last Operator Day?
Well, we talk about moving on from configuration management, but if you just look at the life of people, using Kubernetes, I would say they are still trapped in a world of details, right? You still have to understand an enormous amount about every application that you're trying to drive. You still have to understand an enormous amount about the particular context in which you're trying to drive that application. And of course, Kubernetes now adds a whole new layer of details. It's incredibly powerful. It has a tremendous amount of rich capability to specify and declare your intention. But you've got to specify and declare your intention. You've got a whole extra layer, effectively, of YAML configuration management to provide even more fun for people who previously thought life was a bit complicated. Kubernetes arrived in this blaze of glory, promising to change everything. Lots of new dogma that turns out maybe to be a bit shallow, right? People originally said, everything's going to be immutable, but we know that Docker containers start mutating the moment you run them, right? And we have all these mechanisms now in Kubernetes to mutate containers. Stateless, the idea that Kubernetes was going to really focus on the stateless story. Well, that turns out to be shallow because lots of serious software is not stateless, right? If you really want to run everything in production on Kubernetes, then you can't simplify things to the point of just dealing with the stateless stuff. You also have to really get in and provide many of the low-level capabilities that systems depend on for accurate operations. We've done a lot of work recently with organizations building large-scale, high availability SQL database operations. And of course, you can't throw away 3 decades of hard-earned experience about how you stand up and run serious databases in a highly available environment, right? Databases are all about state. Databases are all about availability, and getting that into Kubernetes, has reminded everybody that there is potentially no easy way. There are no silver bullets, effectively, right? So as much as things have changed, we still get drawn back into some of the old patterns, some of the old challenges, some of the old constraints. Getting things secure in a Kubernetes world, is I think once again rearing its head as a real concern for institutions who've rushed to kind of deploy things on Kubernetes. Thinking about security as really sort of solved through the ability to do rapid rollout of new versions, but not thinking about security of the whole cluster, not thinking about the new classes of attack that come from all the different mechanisms that Kubernetes provides for workloads to talk to each other and so on. So in a sense, those people, institutions who've rushed into Kubernetes now find themselves in, just new versions of old problems. And every big institution now, I think, can tell, their own version of the story of Kubernetes chaos, right? Having lots of different teams that all decided to use Kubernetes, all decided to implement Kubernetes differently, went ahead, charging forward into this brave new world, and have now left the organization with cluster sprawl, right? Lots of different clusters, lots of different operations regimes, lots of different approaches to solving some of these basic problems on top of Kubernetes. So things have changed radically, but the deep underlying problems and pain points, I think, for organizations are still the same.
Mark, we jumped in really fast here. I'm excited. It's interesting stuff. But do you mind if we take a little step back here? and ask a couple of personal questions of Mark Shuttleworth.
Sure.
All right. So, what does everyone want to know? Coffee or tea?
Oh, that's easy. Coffee.
Rock, electronic, or K-pop?
Also easy. Rock.
All right. Okay. I thought it might have gone somewhere else, but all right. Is it better to deploy applications in containers or on VMs?
That's also easy. Yes.
Is the future public cloud or private cloud?
That's not so easy, but the answer is still yes.
Is it more efficient for the enterprise to build a giant monolith or a bunch of microservices?
For most organizations, the answer would be yes.
Is the solution to too much YAML more YAML?
Now we've jumped the shark. The challenge today, of course, is that in large institutions there is no silver bullet, right? Microservices or monoliths. That's going to be a real debate that engineering teams have to have for a long time. Bare metal or containers, containers or virtual machines. I do not see one thing just suddenly magically absorbing everything else, right? We continue to see new things getting built that do best at the raw machine level, and of course all sorts of new things being created that are container oriented. And we're going to have to figure out how to operate and live with those things in a very in a better way, right? Just rushing to Kubernetes isn't going to magically solve our problems. Thinking more clearly about software operations in Kubernetes and elsewhere might solve our problems.
Interesting. You mentioned that there's a. Do you want to go further into that? Is there anything that people should be thinking about, the big questions that when they're trying to solve the needs that they have in their enterprises in different places? What should they be thinking about?
So if you step back and think about software, the real pain for an institution in software, comes in two waves, right? There's the pain of day one, and then there's the pain of day 1000, right? And those are two quite different challenges that every organization is grappling with every day of the week, right? At the same time, right? There are a whole bunch of things that are at day one, new things that the organization is trying to bring into its infrastructure, into its catalog, effectively into its domain, and then you've got obviously lots and lots of things that are at day 1000 that have to be managed, and the old and the new effectively are doing this dance, and people are effectively having to worry about both the old and the new at the same time. But the pain is quite different for stuff at day one and for stuff at day 1000, right? So if you think about day one, right, there's something new, there's something shiny, there's something that you urgently need to bring into the business, a new capability. So what do? You put your best designers, you put one of your best architects on it, and they go and study it, right? They go and work to understand, dig into it, understand how it works, and operationalize it for your business, right? So maybe they're setting up CI/CD pipelines, maybe they are setting up build infrastructure, maybe they are setting up a sort of secure software supply chain. But at the end of the day, they're doing all this exciting work with something new, and they're making decisions, they're making choices. Those choices are real in the sense that they reflect the software and their understanding of the software and your business and the environment that they're trying to operationalize that software into, and everything else that's there. Those are real choices, but they're also unique, right? So they're building a snowflake. They're building a snowflake that is right for that particular set of circumstances, but it's still a snowflake. And that takes time, it costs money, it's pain. Those skills and that knowledge are hard to spread in an organization. It takes people time to learn things, and they're all busy, so it takes more time. So new software comes in slowly and painfully into an organization, even with something like Kubernetes, right? And we're living now in a time when there is more and more new software, right? The emergence of open source hasn't just changed the nature of the software, it's also changed the speed at which new software is getting embraced, right? And so that means organizations have this slow, painful day one process, but they're having to accommodate more and more and more innovation coming into the organization through that slow, painful day one process. And on the other hand, you've got the pain of day 1,000, right? All those original designers, architects, decision makers, they're gone, right? They've moved on. They're doing the new thing. And somebody else is handed this set of decisions and choices that got made 1,000 days ago. The tech stack has moved on. I mean, I remember Kubernetes 1.10 when everybody started saying, okay, that's it. Now we're doing Kubernetes in production, right? Well, there's still a ton of Kubernetes 1.10 production clusters out there, and those things look really quite dated now. They look quite broken through the lens of Kubernetes 1.21. We're all grateful for all the new things in Kubernetes that have come since 1.10, but those production infrastructure, that's a new kind of legacy, right? With a whole set of specific details that you have to know about it, specific issues and choices made in the operationalization of software on those clusters. All of that has to be maintained, and vendors aren't so interested in those old versions. Infrastructure preferences might be changing, but those old deployments effectively lived in a context that can't so easily be changed, right? So everything becomes legacy, and maintaining legacy remains hard, right? So I guess we spend a lot of time thinking about that because we see organizations in that sort of constant state of novation and maintenance. And I think we have a deep appreciation for the fact that we need to do things differently, avoid creating new waves of future legacy effectively. So I guess that brings us to the current state of the art of operators, right? In a sense, they're still down in the weeds, right? Every operator has to be considered. Those standardized ways to think about maintenance of operators or user experience of operators, right? So I think we really need to work at a higher level, or we just end up back in the same swamp.
I think today's going to be a really interesting day as we dig into what can be done with operators and charmed operators in particular. We've spoken a little bit about what people are trying to deal with, the challenges that they're facing, but could you imagine a world where, given operators, people in operations are able to focus on a different set of questions than they're currently facing today, or maybe a specific subset of those questions?
Yeah, I think we have to sort of step back and try to imagine a much simpler world, right? Where we reduce operations to a set of business questions. For example, imagine a world where your operations team, when they're bringing in a new application or maintaining old applications, they're really focused on the key issues. For example, where are we going to run applications? That's a business choice, right? If you're running applications on-prem, if you're running them on bare metal, if you're running them on a particular cloud, those are business decisions. I think institutions are going to continue to say yes to all of those different kinds of infrastructure. So your operations teams are going to have to keep making that particular business decision every day of the week, right? Where are we going to run applications? Which applications are we going to integrate? Anytime you're sort of standing up a solution, you are essentially choosing a set of software components and integrating them. And today that integration gets encoded in a snowflake, right? It gets encoded manually by smart people inside the business making business-specific choices. But what if we could essentially describe that integration programmatically, so that integration code wasn't specific to that business, it was standardized across lots of different businesses, right? So the operations folks aren't actually writing integration code that's unique to them. They're rather specifying a model of that integration, right? They're choosing what integration to implement effectively off a menu of things that are shared across many organizations, right? The third business decision really is capacity resources, right? Two different businesses might deploy the same topology of applications at different scales. So there's a really important decision that each of those businesses has to make, which is, what's the resourcing of that topology? How many cores am I giving it? What kinds of cores am I giving it? In addition to, where is it going to run? What scale is it going to run at? Those are business decisions, right? And then how am I going to integrate this new solution, this new scenario into my broader institutional dashboarding, operations regime, monitoring systems, and so on? You take a very different approach when you're deploying something for dev than when you're deploying something for prod. Even though it's the same stuff, you're going to run it in different places, right? Different clouds. You're going to run it at different scales, and you're going to integrate it into your global dashboarding system quite differently. So these are the real business decisions that people have to make. Everything else is kind of noise. Everything else is, essentially a bit of a trap. If you're making low-level decisions about things that aren't in those categories, well, then you're going to have to remember those decisions. Those decisions are going to be unique to you. They become your own kind of maintenance hell. So, this new world of higher level thinking for operations people, that's something that we're really passionate about. I'm really passionate about. That's the world that we're driving to with model-driven application management, right? Where your operators live inside a model, and the model is where you express those four kind of big business decisions, right? Where am I running this stuff? What am I running together effectively? How am I grouping my applications and integrating those applications? That's the graph, the application graph in the model. How much capacity are we giving that model, right? How many cores are we giving it? How much RAM are we giving it? How much disk are we giving it? Where is it going to draw that disk from? Which pool of disks at what performance rating, and therefore what cost to the business? All of that goes to sort of budget and spend. And ultimately, how are we going to expose this particular set of applications to the rest of the organization, right? Clearly, each set of applications is its own sort of world, its own model with its own operations team and its own kind of priorities, but that has to fit into a bigger whole, right? It has to be part of the broader landscape of the business.
Now we're talking a lot about models here, but is that a namespace? Is it similar to a namespace?
Sure.
What do you mean by that?
Yeah, in the Kubernetes world, it maps very cleanly, right? You take a model and you say this model is going to be on that Kubernetes, and then it becomes a Kubernetes namespace. And so that way you can easily sort of understand how I can put multiple kind of charmed operator models on the same Kubernetes if I want. They each go into their own namespace. But a Kubernetes namespace is really a low-level construct, right? It's something prickly and detailed, and I don't think human operators should be too drawn into that, because they're going to start essentially making traps for future versions of themselves, right? They're going to start creating sort of a new class of legacy down there in the weeds in Kubernetes. Better to stay at a high level, be making those business decisions, and have tooling effectively driving the implementation down into things like Kubernetes namespaces. There are a bunch of key benefits, I think, for model-driven application management. And those would be, right, the idea that all of these components that are getting integrated, they should be documented in the same way, right? It doesn't matter if you're going to be deploying stuff into bare metal. It doesn't matter if you're going to be deploying stuff into VMs. It doesn't matter if you're going to be deploying stuff into container infrastructure like Kubernetes. You want to basically have a catalog of things that work the same way and can be talked about cleanly in a single namespace, that can be composed effectively, and which work in all of those different environments but deliver the capabilities that you're looking for, right? All of those components. So the first thing is that all those components should be packaged the same way. Should be documented in the same way, right? I should be able to refer to them in the same way. Those components should all be maintained by other people. I mean, the average organization isn't in the business of maintaining third-party software, right? Sensible businesses try to get other people to do that work for them. And the same is true, I think, now for this new level of operations code, right? Those components should be maintained by a vendor, or they should be maintained by a community. So that you minimize the number of snowflakes and distractions inside the business, places where the business is investing in operations code for some component that isn't actually written by the business. That's crazy, right? So minimize that, standardize the update and the patching process. And as part of all of that, give the organization freedom of choice for the infrastructure. Decouple the choice of applications from your choice of infrastructure. Sort of crazy that you should be told by a vendor that they can give you a standardized component, but it depends on a specific Kubernetes implementation or a specific cloud, right? You want, as a buyer, you want to choose your applications and choose your infrastructure and then put them together. You don't want complicated interdependencies between that. You don't want a situation where you're trying to integrate 3 different components from 3 different vendors, but they've all locked themselves on 3 different clouds. How are you going to integrate that? This approach then guarantees much faster onboarding of new applications, because there's no need to create unique institution-specific code, and much simpler long-term maintenance, because all of these components effectively coming from standard catalogs with standard procedures and standard documentation, right? So that greatly simplifies the long-term maintenance story, because it means that all the components that are being maintained have a common ancestry, a common sort of set of behaviors. This should be a much, much better world for the organization if we can pull it off.
Mark, I've been looking around through different forums, through chats, through Slacks, looking into the kind of operator community that's being built, and I don't want to date myself too much, but it kind of makes me feel like the early days of DevOps. Back, I remember there was this session in Boston in 2011. Where I was speaking with one of 2 people, and I can't remember whether it was Jesse from Chef or Patrick Dubois, who was one of the organizers of those early DevOps events. And we were talking about the movement itself, about how they were concerned that in 2011, it had already jumped the shark, which was a term that I wasn't really familiar with at the time. I think it has to do something with an old TV show and some guy surfing or something or other and jumping a shark while he's doing it, and that being the demise of that TV show, because it just couldn't get any better than that. But there was this level of excitement at the time. And of course, it's strange because that was 2011, and then the Phoenix project and the DevOps handbook and stuff, that didn't even come out until 2015. And the movement itself is still really growing and going on strong right now. In those forums and when I'm talking with people about operators, it feels like there's that level of energy now in the community. And I know later today, you're going to be doing a session with Ken Sipe about trying to discuss some of that, trying to discuss what operators and what model-driven operations could handle, how could it form, what challenges could it solve? And I know this is going to be more of a community-led session. So for everybody in the audience right now, I think it'll be great if you can put it on your calendars. If the people helping us out with our chat can share links to where that is, it'd be fantastic to see everybody here there, to have more of a private chat, kind of a birds of a feather session with Mark Shuttleworth and Ken Sipe. It feels like we're getting the chance to solve some real problems. Does this feel like one of those nascent moments to you?
Yeah, I think, when something new emerges, there's a lot of excitement about it, but it's sort of disorganized. It takes a little while before you can really see clearly what's going to last from that disruption. And the sort of world of operators right now is sort of full of energy, but it's also in a state of some disarray, right? Some confusion, the fog of disruption, effectively. I think in the conversation with Ken, so Ken is the chairman, or he's kind of a co-chair of the operator SIG under the CNCF. I think in that conversation, we're really starting to step back from the change, everything's new view of operators, and really try to get to the bottom of the values that need to be in place to make this thing universal, to make this thing long-term, to make this thing consumable by people other than the bleeding edge razor blades that are the normal people who drive change effectively. I can think of a similar sort of moment in Linux where we'd seen very, very rapid change and lots of turbulence and disruption. And then, things settled down and people got this very productive platform that they could work on top of. And so suddenly you could get 10x the number of people building on that platform because it had that kind of clarity and certainty, right? So in the world of Kubernetes and operators, I don't think we have that yet. And hopefully the conversation that we're driving this afternoon, well, depending on what time zone you're in, with Ken will be, focused on trying to get that kind of standardization and clarity in place so that people can really start to become productive and not worry about the details under the hood.
Really looking forward to that. That's going to be a great session. I think we might be putting together like a Miro board where people can actually interact and raise a lot of questions, and there'll be some fun activities there.